Cancers are genetic diseases, which is why most of the efforts being put into beating cancer is happening at a genomic level.
Cancers are really DNA diseases. A single cell develops a mutation, which takes a little bit out of its normal growth controls and then slowly develops more and more mutations that let them grow faster and faster and survive better. The more we learn about cancers, the more clever we realise they are genetically and genomically.
By understanding the cancer genomically, we can better understand where it came from and how best to treat it.
Genomics is really helping us inform how we can treat a cancer more specifically, because cancer is one of the most personal diseases we can get. And that also means that we need very personalized treatment.
By using genetic technologies, we identify particular mutations that show an Achilles heel in a tumour. The mutation makes a different shape of protein and the immune system can then attack the cell because it sees that different shape of protein. A targeted drug or a drug that boosts the immune system can hit most of the tumour, but at the same time try to identify what sort of mutations may arise that lead to resistance in the tumour. That can allow targeted therapies to target those specific molecules that are making a normal cell grow out of control as a cancer.
By unlocking the hidden codes within cancer cells, scientists hope to transform the way we diagnose cancer, leading to much earlier detection.
As a tumour develops, it will spill some of its DNA into the bloodstream. You can take a blood sample from someone, and if they have cancer, DNA from their tumour will be present in that blood sample. And we can show its tumour DNA by sequencing, and you will find in there fragments of DNA which contain mutations.
Normally if we take a biopsy of a tumour, we're seeing a single piece of tumour. But if you're looking in the blood, you're seeing all of the metastatic tumours from around a patient's body.
Understanding the genetic risk of certain cancers has led to some world-leading discoveries, such as identifying the deadly stomach cancer that affects a number of families in New Zealand, including the singer Stan Walker.
So there's a number of large families in New Zealand, particularly Maori families, who have about a 70% lifetime risk of developing stomach cancer. We've been identifying individuals from these big families who have inherited a particular mutation which gives them this high risk. Then put them onto either a surveillance program to find the cancer early, or they can have surgery and have their stomachs removed to get rid of all risk of stomach cancer.
With the majority of genomic research being conducted on people of European origin, researchers here say we need to work more with Māori and Pacifica to understand where differences may lie. If we don't, we could end up with even more inequity.
With cancer treatments becoming more individualized, we will still need similar patients to learn what treatments work or don't. We need to really work closely together with our international community to get enough data together to understand what works for that particular cancer type. And one of my big fears is that with genomics, that could increase that inequity. Because if people are unsure about whether genomics is safe and if people are handling the data appropriately, they're not going to get genetic testing.
Right now we have a real challenge in that we don't even know what the baseline genomics is for large parts of the world. Genomics is very unequally applied in terms of our knowledge, and that's going to limit the achievement of equity in our therapies.
There is a real chance for us to do things differently and take equity into account and to design our system in such a way that we're not going to increase inequity. So one of the things I think we can do is to start those conversations with our indigenous communities. They've already written guidelines on how to do genetic testing appropriately and rethink some of the key concepts.
While there may never be a simple cure for cancer, these researchers believe we're on our way to cancer becoming a much more manageable disease in our lifetimes.
In the future, we will have the entire genome sequenced, if not at birth, soon after birth. And so your GP will have a record of the cancers or the illnesses that you're at high risk of getting in your lifetime. It'll be a disease that you will survive. I think the way we fear the disease today, that will no longer be the case for our children and our children's children.